Very big round of applause and welcome him.
Good evening, ladies and gentlemen. I understand it's a pretty long day of knowledge sharing. I don't want to stretch it long. Just to give you a brief, I am quickly here to give you some cabling trends on data center based on the global standards and what we at CommScope are doing for it. Myself, Amit Chakraborty, I take care of the technical sales for CommScope for eastern part of the country and as well as countries like Nepal, Bhutan and Bangladesh. So, so talking about CommScope, as most of you would already be knowing, we are all about, the technology leaders and leaders globally for communication and connectivity services. So wherever you find connectivity, you find CommScope. And very frankly speaking, today as we talk, connectivity is everywhere around us. Whatever we do, however we live, wherever we live, we are surrounded by connectivity. We are surrounded by networks all around us. It can be a wireless network to our handheld devices, smartphones. It could be wired networks in our offices and all the way back to the data centers. So all around we see connectivity, and at every single stage of connectivity, CommScope has a product or a patent or a technology to support that. Just to give you a typical legacy of CommScope, we all started from a two-way radio communication system company from back in the 1976. And as we had been the visionary in technology leadership across the globe, we have always, we had been agile enough to adapt to newer technologies, newer solutions, and in line with that, keep up with the trend in the industry of communication and network sharing as it has evolved. So strategically, we have acquired companies like Systemax for their structured cabling business back in 2004. We acquired Andrew Telecom for their RF antenna solution for RF mobility signal coverage in 2008. 2015, we acquired a T connectivity business, which was the AmpNet Connect and ADC Chrome business for their huge fiber portfolio that they were leader once. And as we talk, just last month, this year, we completed our another biggest acquisition, which is of the Aris network, who are again a very big player across the globe for entertainment and broadband solutions. And along with Aris, we also have now the Ruckus Wi-Fi systems for the wireless LAN in campuses, as well as the Ruckus switching segment for campus switching solutions. So put together with CommScope after the Aris acquisition today, as we talk, CommScope is a globally $11.2 billion company, and with a capacity to reach to any of the customer's demand, wherever the customer need a network or a coverage, we are there with our solution and products. Be it their residents with their CPE equipments from Aris and to the last mile access drop on fiber from the CommScope, legacy CommScope fiber portfolio, all the way to the campus and venue networks, even large stadiums, wherever we see a huge demand of bandwidth and internet coverage which is required, and up to the macro and metro level enterprise systems and coverage, especially the smart cities that we talk about. We see a huge demand of smart city going on, implementing across the globe. So there again, CommScope plays a vital role with our high fiber counts and outdoor fiber handling equipments. So just to give you some quick cabling trends on the data center, we all have been listening from the morning that data center, it's all about virtualization, it's all about migration towards the cloud, it's all about that huge and instantiable bandwidth demand and the edge computing and how we can adapt to more and more bandwidth and lower latencies, and also support the increasing IoT demands from a campus or a user's experience. Some interesting global trends which has been seen over the last 5 years. We have seen mobility data to grow by 10 times between 2014 and 2019. We have seen IP video grow by 4 times in this span, cloud data 3 times, and internet speed by 3 times, and broadband by 2 times. Obviously there is a dip because it's more on the internet and cloud now. So another important or interesting roadmap from Ethernet Alliance is on the roadmap of speeds that we are talking about today, especially on the data center segment. We already see these speeds in development, which are these purple dots. Like you see this 10G, 40G, 100G, then 2.5G, 5G for the campus environments. So these are all there today for to be achieved on the campus networks. And especially when we look on the data center segments, IEEE is working on the next generation speeds of 400 Gbps, 200 Gbps, and as we look into the 2020 landmark, which is just 6 months down the line from here, we are already talking about some Gbps of 800 Gbps and beyond, close to 1 to 2 Gbps and beyond very soon. So to cater to this, we can understand that there's a lot of fiber that is going to be deployed all across up to our homes, in our campuses, and obviously in the data centers. So when we talk about data centers to support all these fleets, we have different fiber technologies ranging from duplex fiber using duplex type patch cords. There are parallel transmissions for traditionally for 400 and 100 Gbps and higher bandwidth systems. And now the latest trend has come where you have a combination of both. You have duplex fiber and parallel lens, on which I'm going to talk about in detail in a little while. So we have seen the impact of virtualization and cloud from the morning. There have been some lovely presentations from some of the cloud providers. It could be, so cloud data center is definitely on the rise, be it a public cloud or a private cloud. It's definitely on the rising segment. Edge computing, because of the IoT impact and then huge bandwidth and speed demand from multiple devices across us in our lives, in our daily lives. As we can see that in one internet minute, what are the things that goes around globally? You have some 216,000 of photos posted on Instagram. You have more than 1,300 of Uber rides booked. You have more than 200K of Amazon dollar business worth of business done on Amazon, and so on. So with this, we get an idea of how critical the bandwidth and the connectivity is for today, even for a handheld device and a user level CPE component. We also have some of the disruptive network technologies which has affected the design architecture of the data centers today. Primarily we talk about the 3-tier architecture, which was, now this tier is not about the uptime or the TIA 942 standard. This is more on the architecture of the active switching design, which was traditionally always on a core aggregation and edge or access switching layer. Which was more of a north-south based traffic, wherein latency was always an issue because of different and multiple decision-making layers across the core switch and the access layer and server switches or the compute segment. So now the new standard which has been recommended and which has been widely implemented in major hyperscales and NDCS are the Tier 2 standards or the leaf and spine network, wherein you see a mesh fiber architecture between the leaf and the spine switches, and there you have a more of a east and west traffic, so you have much more control on the latency, which is one of the critical parameters for the data center designers today. So we have seen that what are the priorities for designing and implementing a data center today. The top priority is how do we handle bandwidth, how do we manage the constant exponential growth of bandwidth. How do we manage and implement virtualization and cloud systems, and how do we manage latency, obviously. And the need to address these challenges or roadblocks is to have a system that is simple or very easy to manage and scale on the bandwidth level. It should be efficient so that it can adapt to different changing technologies, maybe from a traditional technology to a cloud technology and so on. and it should be, high-speed migration or speed migration should be supported in that, so that we can migrate existing customer from a 10G network to a 100G or a 40G network based on his demand. So at CommScope, what we do is we have created, based on these problem areas and the needs of the market, we had strategic solutions on the high-speed migration portfolio. How do we scale a data center? How do we manage the cloud services, and how you can scale at a cloud data center level? And with so many networks coming in, so many connections going across, so many cables going across the racks in the data center, how do you manage the entire infrastructure? So these are three critical solution and again priorities that needs to be taken care of while designing. So first we address the high-speed migration. We do have a portfolio where we support at least 3 generations of systems to be migrated on a fiber infrastructure from a 10G to a 40G, maybe of 25G in between, and all the way to 400G without changing a single piece of connector in the entire cabling channel. So that's the kind of modularity we are talking about here. Support for different MPO connectors. Obviously, talking about fiber, we all know the necessity is predominated fiber systems with MPO connections. So we do give you all the varieties of it. It's a 8 fiber MPO or a 12 fiber MPO or a 24 fiber MPO, depending on the need and the efficiency requirement of the customer. Ultra low loss to take care of the performance and the latency and to enable more and more connections in a channel. High density and ultra high density shelves, so that you can have more number of ports in the given space, because space cost is always at a premium. AIM, or the intelligent solution to have overall management of the systems. And the game changer really here is the OM5 wideband multimode fiber cabling, which was a child of CommScope, we can say. And then we also give you some calculators and guarantee on performance and applications that whatever we design, you get once you implement. So those kind of tools and support stuffs are available. So talking about the MPO 24, 12 and 8 options, there are certain benefits, pros and cons for each of them. Definitely for more hyperscales or more fiber counts, it's always suggested that you go for MPO 24 so that you have future ready and lower fiber cable count. Now this gives a nice analogy of this. For a given number of fiber ports, if you are using MPO 8, you would need 8 fiber trunk cables, whereas using MPO 24, definitely you need only 1. So you can drastically reduce the cable volume inside the data center, which would have an indirect effect on the airflow and the other efficiency and ultimately the PV of the data center, as you can minimize the cable volume, bundle volume there. We also have the ultra high density and high density shelves to give you more space and management options. Now here, just to give you one example, like the Systemax UD shelf gives you on a 2U platform, you can actually terminate 288 fiber cores or a 144 duplex LC. That too, with full manageability. These are all available with AIM enabled features. When we talk about high density, it's not about how much port you can populate. It's also equally important that how easily you can manage them. So for that, we have this kind of split tray design, as you can see in the top right corner of the UD shelf. So half of the tray you can pull out, so that the all in a 100% connected and populated patch panel, the connected interfaces are not disturbed. So you have a very easy access inside that. So talking about OM5, which CommScope initiated this, worked on this technology called wideband multimode fiber. We initially called it as WBMMF, which could give you 4 times the capacity of OM4 fiber, and it uses wave division multiplexing technology, which was used in the single mode for FTTX networks. The same technology has been applied on a multimode network, and we had developed this wideband multimode fiber. As you can see in a typical multimode operation, on that graph, on the yellow or the green pillar, that shows the 4 virtual wavelengths on which the OM5 does its transmission. so that on a single core of fiber you have 4 parallel virtual lanes. So that now for a 40G or a 100G transmission you don't need 10 lanes of fiber, only with one core or a duplex patch cord you can achieve this. So CommScope was working on this since 2014-15, and initially, and when we presented these products and solutions to the TIA committee, finally the TIA and the ISO committee approved and published this out as a standard which is available today under the TIA 492 AAA, and they have branded it as OM5, which is the 5th generation of multimode fiber cabling. So that's the analogy of how OM5 helps you in terms of reducing the fiber count. Now the blue color lanes, those are the typical regular OM3 and OM4 deployments, wherein you need up to 8 cores of fiber for 40G, 20 cores of for 100G, whereas with the WDM or SWDM technology on OM5, you can only use a duplex cord with those virtual 4 lanes inside that one single core of fiber. You can achieve up to 100 Gbps on a duplex cord of duplex fiber patch cord. So the real benefit is shown in this. So for a 10G base SR, when a customer want to migrate to a 10G base SR4, he need to change the MPO trunk patch cords on the front and also the MPO modules or the cassettes that he have implemented using a OM3 or a OM4 legacy fiber system. While if you use a OM5 system from day one, which is also backward compatible to the existing multimode fibers, from migrating from a 10G base SR to a 100G base SWDM4, there is not a single patch cord being changed in the entire infrastructure. So now this is the 3 generations of migration through the high-speed migration portfolio that I was talking about, which helps a lot in hyperscales and big-scale data centers where cable management becomes a big issue without these kind of implementations. So at CommScope we have an entire fiber portfolio, starting from the fiber entrance facility terminals all the way to the ODF frames, high density ODF frames, where in one single frame we can have up to 4,000 fibers terminated. We have all the specially designed fiber guide system and the pathways. We have the specialized MPO trunk cassettes and cables. And last but not the least is obviously the management system, which comes under the AIM portfolio. So managing the infrastructure, as I said, that as we increase the number of ports, increase the number of cables inside across racks in the data center, it becomes very critical to physically see that where these ports are going, if there is a connection or a disconnection happening across where exactly that event has happened, and how quickly I can troubleshoot that event or that error. So with AIM, it gives you the real-time view of the physical layer, which probably none of the other NMS or the DCIM softwares gives. It gives you the real-time view of all the individual cabling connections that you have across the copper and fiber panels inside the data center. It gives you a 2-level view, both at the rack level with the use of this kind of a LCD display controller, as well as through a fully-fledged, fully functional software which runs at the back of it. Now, good thing is that CommScope had been working on this vision and management solution for the last almost 15 years. But good thing is that in 2016 and 17, ISO IC and the TIA have approved this as an AIM standard, and there are set of guidelines to follow and meet these specifications there. So some of the key takeaways are managing all the aspects of the data center. It can even track and manage the OSP cable terminations, OSP outside cable pits. If you have, you can manage them. End-to-end physical layer monitoring and cable routing and bend management can also be controlled through this. So what are the system components that you need for intelligent system? It's just that every rack where you have this intelligent system, you need a rack controller with the visibility. This controller in turn connects to the intelligent fiber and the copper panels which are at the rack, and then at the back end, the controller communicates to the software for the entire view. We have a live demo of this entire system in our stall outside. Anybody interested? I think a lot of you guys have already visited. If anybody want to have further details, we can always share. Now this is the visibility that you get from point to point with all the intermediate interconnections that are there, especially in terms of a data center. When it comes, it is more critical because in data center there are arrays of rows of racks, servers, and multiple devices across different rows. So there it gives you the power of visibility, knowledge, and full control of knowing and identifying and reporting each and every event on the cabling panel that is having. And you can also plan for future upgrades, getting to know what are the existing occupancy of the panels. As I was mentioning, we also have the fully functional fiber guide and copper pathway systems to take care of all your fiber and copper cabling, cable routing across the data center and all the way from the mux rooms. These are specially designed, fire-rated and low smoke zero halogen component products which are specially designed for data center appliances. We do have a huge basket for this, and also multiple softwares are there to help you on the designing on the BOQ generation for this component. So just to sum it up, we have the connected and efficient data center end-to-end portfolio all the way from the OSP to the mux room to the entrance facility to the fiber routing and the copper routing systems. When you come to the computer hall, we have the MDA segments where we have the high density fiber and copper systems. Then we have the server where we have the flexible and panel frames. We have the high density cabling trunks. And finally, to manage the entire system, the AIM system or the Envision software for CommScope that goes across. Some of the key differentiators of CommScope is always the method B enhanced, because for fiber, always managing the polarity is a big challenge at the site. So we always have these method B enhanced systems which uses a uniform polarity which can be managed at the site without any error. And we also support these ultra low loss for latency problems, latency issues, intelligence, MPO24 benefits, full high density panel portfolio, OM5, big game changer for the hyperscales and the MTDCs space for migrations, and obviously the application assurance program that we have to certify the installations. So that would be it. I would just run through it. So any questions, we can take it, or we are out there at the stall on R6. We'd be happy to address your questions. Okay? Thank you so much.